Okay, here I bring another example. So this is related to the financial portfolio diversification. So maybe the finance is the economic application where the correlation is most important, most widely used. So like and like the very basis for the financial economics is based on statistics that I'm going to demonstrate like in this video and maybe in the following video. So let's simplify the situation. There are only two financial assets. You can think it as a stock market in the United States and in China, or you can think A is like a bond, B is stock, or you can think A is Apple, B is Amazon, whatever. So just suppose that there are only two financial assets on which you can invest. And the returns depend on the economic state. And simply, I will consider three states are available, like possible. One is boom, and the other, another is recession, and the normal is none of them, none of the others, right? So I'll assume that asset A is pro-cyclical and risky. So pro-cyclical means the value of asset A increases when the economy is in boom and goes down in recession. But B is a cyclical asset. That means B's return increases in recession and decreases in boom. Like for example, luxury goods market, luxury goods firms like Chanel, Louis Vuitton are like pro-cyclical. They sell very well in the boom, but they collapse during the recession. However, like a cheaper brand, like a low price brand, are doing better in the recession than the boom. Like so, that's just conceptual background. And I will just put some numbers, give some numbers on the probability of each state. Say you can think of it this way: next year, the economy will be in boom with 25%, in recession 25%, and normal, nothing special, with 50%. And in each case, in each scenario, the asset A will give you, say, 20% of your investment, 80%, 4%. Or you can put it as $20 or say $20,000, $20 million. Does not matter. So you can put any unit there. And on the other hand, asset B returns 6, 10, 14. So that is highest return is given in recession and lowest return in boom. But A is more like pro-cyclical. And also, I call A as risky asset because the difference variability is larger. A varies from 4 to 20, but B varies 6 to 14. So of course, if you calculate, you need to calculate the standard deviation to rigorously compare the risk in asset A and B, but just at a glance, it's, I think, easy to tell. Okay? Then, what we are going to do is we would like to calculate the covariance between these two assets. So there are two assets, and their covariance becomes very important in financial portfolio, right? Let's first calculate the covariance. In this case, the major difference from the earlier examples is that we have probability in our examples of like temperature and economy or the macroeconomic variables. We just observe over time. So it's like raw data. But in this case, I give you probability. So that is, so in each probability, so A's return is 20 with 24%, 25%, and 8 with 50%, 4 with 25%. So each outcome has these probabilities. And B also returns 6 with 25%, 10 with 50%, 14 with 25%. So the probability is associated for each outcome, right? But and then we know how to calculate the covariance. First, calculate the expected value, the average of A. Expected return of A is 10. I'm not going to show you how to calculate that. Use the probability and calculate the weighted sum, weighted outcome, and sum them. That will give you the expected return for A, which is 10. And similarly, expected return for B is also 10. So expectedly, those two assets are the same on the basis of their expected return. But okay, so after calculating the expectation, you calculate the deviations, transform the outcomes into the deviations, then 28 for the A's outcome for A becomes plus 10 minus 2 minus 6. So relative to the expected return of A. And similarly, the outcome for B, 6, 10, 14 becomes minus 4, 0, plus 4. So also relative to their expected return. So after calculating the deviations, we are going to multiply them. But at the same time, when you multiply, after multiplying those cross product, also you have to weight them by the probability. So before you sum, you have to weight them. So usually without the probability in the earlier examples, we multiply them and sum. But now, because there are probabilities, you multiply the deviations, and then before summing them, you additionally multiply the probability. So in the first case, in the first scenario where the economy is boom, and then 0.25 times plus 10 times minus 4 becomes minus 10. And the second case, 0.5 minus 2 times 0, 0. 0.25 minus 6 times plus 4 minus 6. So these three are probability weighted cross products of deviations. So this is the definition of covariance, right? Excuse me. So remember, sum of something weighted by the probability is the average. So in some sense, this is the average of the cross products of deviations. But just to elaborate, the average is calculated as the sum of probability weighted outcomes. So we used the probabilities for weights, and then as a result, the covariance between these two assets are negative 16. So they are negatively correlated. That means when one is doing better, the other is going down, and vice versa. So this is actually very good in financial risk management, because when one is going bad, it's compensated by the other. So you are more safe. Your risk is hedged. We call this hedging, right? Risk is diversified. We are going to formulate that by considering an investment on both assets. So simply, we will see what happens when you put the same amount of money on both assets. Previously, suppose you invested, say, $100 on A and $100 on B. Now you invest both with $200 total. And remember, we are going to measure the risk using the variance, right? Or later, the standard deviation. And we will study, main goal of this study is to see the effect of negative covariance on the risk. So as I said, negative covariance does really a good thing for to minimize the risk. So I will illustrate that. Now I will call this a portfolio. X is your portfolio, and in this portfolio, you invest on A and B at the same time. So your return is sum of them, summation of like both assets, returns from both assets. So in each economic state with the same probability, you get these much returns, outcomes, but in the end, your portfolio will have these outcomes, right? In boom, your portfolio will have 26 and 18 and 18. So this is the final outcome of your portfolio. And now let's calculate the variance of this portfolio, how you calculate the variance. Before calculating that, I will just realize it's your turn. So variance of A is, if you calculate the variance of A, it was 36 and the variance of B was 8. So variance of A is larger because it's more risky. And now you invest on both. So without calculus, without any algebra, try to guess what would be the variance of the portfolio X, defined as the sum of A and B. Okay, so I'm just asking you what so I will show you how it works. I just want you to guess, just conjecture what would be the variance. I think like C makes more sense because you observe two risks at the same time. You take both risks at the same time, so maybe your portfolio should have both risk at the same time. But let's calculate if this is true. So this is the outcome, 26, 18, and 18 for each case. Remember that the expected value of X is 20 because mean of A is 10, mean of B is 10. So their sum, mean of X is 20, some of them. So the mean is 20. And then remember, we take the deviation of X and then square that and then weight by the probability and then sum. This is how we calculated the variance in chapter 4. Then as a result, you see 12. So this is surprising. So that, like, look at this. If you invest $100 on asset A, then the risk is 36. The risk from A is 36, but suppose that you additionally invest on B. So actually, in some sense, you are taking more risk, but actually in the end, the risk is smaller, even if you invest more. So additionally investing on B it reduces the total risk. So it does better. It's strictly better than just investing only on A. So this is because of this formula. I'll show you how this works. So what we are going to do here is we will look at this summation of A and B. So the original variables are A and B, and you define a new random variable X. We are interested in how to calculate the mean and variance of the new random variable X. First, the mean is pretty simple, straightforward. The mean is just the sum of two means, so it's not a big problem. But the variance is not the standard formula. Variance of X is not just the sum of variances. So variance of sum is not the sum of variances, but sum of variance plus additionally you have covariance term, 2 times covariance. You can just understand this as the expansion of quadratic, the square of the summation. So square of the sum is sum of squares plus 2 times cross product. Same thing. So you can understand variance as a kind of square. Actually, we square as a one step in the variance, right? So then variance of x is sum of variances, and additionally you have to consider 2 times cross product. And covariance includes, it's naturally a cross product. So when you calculate the covariance, so that these two formulas take the same form, pretty similar formula structure, right? And then standard deviation is simply square root of that. There is no simplification than this. Okay, so then you can see why having B can reduce the covariance, the variance of your portfolio. In our example, variance of A is 36, variance of B is 8, covariance is minus 16. That means variance of A can be calculated as variance of X is calculated as 36 plus 8 plus 2 times minus 16. So from this term you are adding 8 but subtracting 32. 32 is subtracted by the covariance, which dominates the variance of B, so it reduces the variance. Yeah, expectation is simple, so I'm not going to explain anymore. So negative covariance is super powerful in risk management. You can hedge the risk, reduce the risk by investing on negatively correlated assets. But however, theoretically this is great, but in practice it's really difficult to find negatively correlated assets. So that's the difficulty in financial risk management. Okay, so then we can think more about this. So now let's define the risk as the standard deviation, which is more common. So standard, you know, standard deviation is a modification of the variance to be consistent with the unit. So let's take standard deviation as the measure of the risk. Then when does it happen? We are wondering when your portfolio has the same risk as the sum of two portfolios, the sum of the single assets. And this means if for this equality to hold, this means if you square both sides, the variance of x must take this form. Simple expansion of square. And then if you compare this equality to our previous formula, both equations imply this part must be the same. So when there is no risk diversification, the multiplication of standard deviations must equal to covariance. So this is the no risk reduction case, but you can by rearranging the standard deviations on the denominator to the denominator, remember it becomes the correlation. So the no risk diversification condition becomes correlation equals to 1. So the covariance equals multiplication of standard deviations. That implies correlation equals to 1. That means risk diversification does not happen only when the correlation is 1. That means correlation equals to 1 means it's perfect correlation. Of course, you cannot find any two assets that have the perfect correlation. It's nearly impossible in reality. So that means, in other words, almost always you can reduce risk by diversifying your portfolio. So let me repeat. So we learned mathematically it shows that risk diversification does not happen when correlation equals to 1. Then equivalently you can say that whenever the correlation is not 1, you can enjoy the risk diversification effect. And of course, in practice, correlation is never one. Like almost all the assets are different, so they cannot be perfectly correlated. So that means whenever you invest two assets, there is risk minimization, risk reduction. So this is a very powerful implication. Okay, so then the other case, in the other extreme case where the correlation is -1, what happens if two assets are perfectly negatively correlated? In that case, the largest possible risk diversification takes this form. So because we can use the formula, using this formula, when the correlation is perfectly -1, that means covariance is minus 2 standard deviations, minus multiplication of standard deviations. So according to this formula, replace covariance with minus standard deviation multiplications. Then remember, a squared pb squared minus 2ab is the expansion of a minus b squared. So you can rewrite this way. That means by taking square root on both sides, you can conclude standard deviation of your portfolio X, which is a plus b, equals standard deviation of a minus b. So when you additionally invest on b, that much risk is perfectly deducted from the original investment on A. So that's the maximum risk diversification. In an extreme case where standard deviation of A and B are the same, the final risk will be 0. So that's the maximum. But if the standard deviations are different, so like adding additional investment will perfectly reduce that much risk. Okay. And then finally, another interesting case is where the correlation is 0. When correlation is 0, that means covariance is 0. When covariance is 0, the variance of X equals this guy. And we have this inequality because additional term is missing, right? So that means standard deviation of X is smaller than your portfolio. Risk in your portfolio is smaller than the sum of risks in each asset. That means even if two assets are uncorrelated, independent with each other, still they help each other. They help each other reduce the risk. So risk reduction is more universal, more ubiquitous in any assets. So it's very powerful tool in investment. Okay. So I'm going to make the model a little more complicated and more realistic in the next video, and we'll show you some more algebra and interesting outcomes. Okay. See you in the next one.